In this section, we're continuing to learn about circles, but what we're going to do is we're going to be talking about inscribed angles. So, an inscribed angle is an angle with its vertex on the circle. I want you to take a look at the vertex right here. It is where on the circle. The vertex of the angle is on the circle, with two sides that are chords. An intercepted arc is the arc that lies between the endpoints of the inscribed circle. So the red is pointing at the angle, and here is the intercepted arc. The degree of the inscribed angle is half the measure of its intercepted arc. So here's the formula right here. So anytime we're trying to find the angle, we're going to write the angle is equal to 1/2, and we'll put a big A to represent the arc. Next, let's talk about intercepting diameters. We know what a diameter is, so the diameter goes through the center. So basically, if an inscribed angle intercepts a diameter, then, too many thens in here, it is a blank angle. What type of angle do you think it is? You got it. It's a right angle. So we know the formula is the angle is equal to half the arc. So if our angle is 90 degrees, 90 is equal to half of what? Okay, so we will multiply both sides by 2, times 2 times 2, and that'll give us 180 is equal to x. So this arc here is 180 degrees. Next, we're going to talk about overlapping arcs. So if two inscribed angles intercept the same arc, then the angles are blank. So take a look at this. We have angle C, which is right here, and the arc that goes with angle C is AD. Well, take a look at B. Extend the legs or the subchords of B, and we have that same arc. So what do you think it is? There you have it. The angles are congruent. So the measure of angle ACD is equal to the measure of angle ABD is equal to the measure of angle ACD. So if the angles are the same, the arcs are the same, and so we use the same formula. Let's try problem number 1 in your booklets. The first thing you have to notice is that we're working with an inscribed angle. So the first thing you want to do is write the formula. So we have our formula. The angle is equal to half the arc. Do we know what the angle is? No, we don't know what the angle is. So the angle is going to be the variable. So the angle is equal to half. The arc for that angle is 62. So half of 62 is equal to 31. So the measure of the angle is 31 degrees. Take a look at number 2. We see an inscribed angle. Take a look. The angle is on the circle. The vertex of the angle is on the circle. So we write our formula. The angle is equal to half the arc. So in this case, we're given the angle is 113, and it is equal to half the arc, and we don't know what the arc is. So to solve for x, what we're going to do is we're going to multiply both sides by 2. So when we do that, the 2's cancel out. We're going to multiply the other side by 2, and we get, yes, x is equal to 226. The angle is equal to half the arc. Take a look at number 5. We see an inscribed angle because we see the angle K is right here on the circle. First thing we want to do is start off with the formula. The angle is equal to half the arc. In this case, we don't know the angle and we don't know the arc, so we're going to have to figure some things out before we get started. Now, what we do know is we know the entire circle is 360 degrees. We do know that the arc right here from here to here is 65, and the arc right here is 53. So what we're going to do is we're going to subtract those numbers from 360 and see what we get. Okay, so we find out that this part of the angle, this part of the arc is 242. So we are ready. So we go back to our formula. We're looking for the angle. The angle is equal to half the arc, and the arc is 242. We take half of 242, and we get that angle JKL is 121 degrees. The next problem, we're looking for angle RST. We go from R to S to T, so we're looking for this angle right here. It is connected to this arc, so we need to find that arc. What we do know about this problem is that the whole circle adds up to 360. We know from here to here is 75. We know from here to here is 139. And we know from here to here is 54. What we're going to do is we're going to add these numbers together and subtract them from 360 and find out what the intercepted arc is, RT. Now that we know our intercepted arc is 82 degrees, we write our formula. The angle on the circle is equal to 1/2 the arc. The angle is equal to half of 82. So angle RST is equal to 41 degrees, so we'll write 41 degrees. We got to figure out how much is angle RUT. Let's go from R to U to T. Basically, they share that same arc. So if the arcs are the same, the angles are the same. So this also is 41 degrees. For number 7, what we want to do is we want to look at the picture and find out where's the angle. Take a look. The angle is on the circle. So we always start off with our formula. The angle is equal to half the arc. What we're going to do is we're going to fill in the given information. The angle is represented by 8x minus 9, and the arc is represented by 158. We're going to take half of 158, set it equal to 8x minus 9, and we're going to solve it. Hit pause, solve it, and see if you get the correct answer. 8x minus 9 is equal to 76. How about it's equal to 79? Add 9 to both sides. 8x is equal to 88, and x is equal to 11. Let's try the next one. For number 8, I can see that angle M is on the circle, so I'm going to use my formula. The angle is equal to half the arc. I'm going to substitute in the given information. The angle is 67 degrees, and that's equal to half the arc. And the arc is represented by 4x plus 58. To get rid of the fraction, we're going to multiply both sides by 2, and we get 4x plus 58 is equal to 134. Let's go ahead and subtract 58 on each side, and we'll write down that 4x is equal to 76. We'll divide each side by 4, and we get x is equal to 19. We could always plug it back in just to make sure that that arc is twice the measure of the angle. Number 9 looks a little different. I can see here that angle X is on the circle. It is inscribed. And so I could write my formula down that the angle is equal to half the arc. I can see that the actual endpoints here represent a diameter. So I know the angle is going to be half of 180. The angle is represented by 13x minus 1, and half of 180 is equal to 90. Let's go ahead and solve that, find out what x is, and then we can move on. We find out that x is equal to 7. There's a couple of ways to do number 10. We could build on prior knowledge by finding the information in the triangle, or we can stick to using our inscribed angles. I'll do both ways. We'll start off, we know that the angle here, W, is on the circle, so we start off with our formula. The angle is equal to half the arc. We also know that X is also on the circle, and we also know that the angle is equal to half the arc. So if that's the case, if this angle, which is 114, is equal to half the arc, we can multiply both sides by 2, multiply this side by 2, multiply this side by 2, and we get x is equal to 228. So this part of my arc is 228 degrees. So now I have, taking a look at my whole circle, I have that from here to here is 228. And I have from here to here is 78. The whole circle is 360. So I'm going to subtract this from 360 to find out what this part of my circle is. And I find out that part of the circle is 54 degrees. So if that arc is 54, we know the angle is equal to half the arc. And so the angle across from that is 7x plus 6 is equal to half of 54. So 7x plus 6 is equal to 27. We subtract 6 on each side, we get 7x is equal to 21, and x is equal to 3. Whew, that one was quite a bit of work. Take a look at number 13. When I look at it, I can see that I have an angle that's on the circle, so I'm probably going to use my angle is equal to half the arc formula. Well, STU is the actual angle, and it's represented by 5x minus 16. The arc SU is 12x minus 50. So 5x minus 16 is equal to half of 12x minus 50. A couple of ways we can do this. We could definitely multiply both sides by 2, which we're used to doing to get rid of the fraction. So I'm going to multiply this side by 2, and I'm going to put parentheses and multiply this side by 2. When I do that, I get distribute, and I get 10x minus 32 is equal to 12x minus 50. Go ahead and solve that and find out what x is equal to. And we find out that x is equal to 9. You can plug it back in to make sure it's correct. This next one, angle ABD, so I'm going from A to B to D. This angle is on the circle. They're giving me that information, so I'm definitely going to start off with an angle is equal to half the arc. The other information they're giving me is angle ACD. Angle ACD, I'm going to do that in blue from A to C to D. And what I notice about both of those is that they actually share the same arc. So we talked about it earlier. If they share the same arc, then the angles are going to be equal. X is equal to 5.